Hello, everybody. Let's solve this inequality. Absolute value of x minus 2, closed absolute value, less than or equal to 3. Before we do this, notice that we have numbers -5 to 5, and let's use these numbers to get some kind of let's use these numbers between -5 and 5 in order to get some kind of idea of which numbers will work and which numbers will not. So let's first start with -5. Okay, so we're going to take the absolute value of -5 and make it be less than or equal to 3. Absolute value of -5 is 5, less than or equal to 3, and that's false. So a -5 inside the absolute value is not going to work in this case. So let's jump to -4. Absolute value of -4, we want that to be less than or equal to 3. Absolute value of -4 is 4, and is 4 less than or equal to 3? Well, that's false also. So now let's jump to -3. That's the absolute value of -3 is less than or equal to 3. Absolute value of -3 is 3, and is 3 less than or equal to 3? Well, that's true. And so -3 will work. So let's highlight that. Okay, let's try -2. Let's see, absolute value of -2 is less than or equal to 3. Absolute value of -2 is 2, less than or equal to 3. That's true also. So let's highlight that one. All right, -1. I think it'll be the same kind of case, but let's try it anyway. Absolute value of -1 is 1. And is 1 less than or equal to 3? Well, that's true. So as expected, 1 or -1 rather will work. But now will all the numbers after -1 work also? Well, let's jump to, say, 3. Absolute value of 3, is that less than or equal to 3? Let's see, absolute value of 3 is 3. And is 3 less than or equal to 3? That's true. Okay, so I think all these numbers up until 3 will work. Well, let's try 4. Absolute value of 4, is it less than or equal to 3? Let's see, absolute value of 4 is 4. 4 less than or equal to 3. Oh, that's a false statement. So it doesn't work when x is 4, or actually when we have 4. And I think by 5, with 5, it'll probably not work either. All right. So I think it's safe to say now that all of these highlighted numbers are numbers that will work when the absolute value is less than or equal to 3. And these are precisely all the numbers that are between -3 inclusive and 3 inclusive. All right, so let's use this idea to go back to the drawing board and solve absolute value of x minus 2, closed absolute value less than or equal to 3 more directly. Okay, so to be between -3 inclusive and 3 inclusive, we're going to write -3 here and less than or equal to, because we want to include the -3, x minus 2. So what we're doing is we're taking out the contents of the absolute value. So put a -3 here, type less than or equal to, and then rewrite the contents of the absolute value, but drop the absolute value symbols. So we'll just have x minus 2, and then less than or equal to 3. All right, so this is all of the numbers. So x minus 2 itself is between -3 inclusive and 3 inclusive. All right, now what if this was a 4 instead of a 3? Well, we would put -4 here. Always do less than or equal to. Contents of the absolute value are written here, and then less than or equal to, and then put the given number 4. Or if this was a 5, we'd have -5 here, x minus 2, and then 5 there. So in general, if we have less than or equal to a positive number, then change the sign of the positive number, put it right here, and then less than or equal to. Take out the absolute value contents, put it right here, less than or equal to, and then just bring down that number. So that's how that works in general when you have an absolute value less than or equal to any positive number. All right, now let's try to get the x by itself. So we'll add 2 to both sides. All 3 sides, rather. So -3 plus 2 is -1, less than or equal to x. The 2's go away, less than or equal to 5. All right, so this means that the answer is all of the numbers between -1 inclusive and 5 inclusive. So let's say that on a number line. Okay, now -1 is indeed a solution because it is true that -1 is less than or equal to -1. So to include it, we put a solid dot like that. And then by the same token, because we have a less than or equal to by the 5, we do want to include the 5. And so we'll put a dot right on 5. And we want everything in between, so we'll shade all that stuff in between. Now we can use this graph of the solution to write the interval notation solution. So we'll put -1, and since we want to include the -1, we'll put a bracket, and then comma 5, and likewise we want to include the 5, so we'll put a bracket. And that's the answer in interval notation. So this is all the numbers between -1 inclusive with the bracket and 5 inclusive with the bracket. Now let's use the same idea to solve absolute value 2x closed absolute value less than 3. All right, so we'll change the sign from 3 to -3, put less than or equal to, put the contents of the absolute value, which is 2x. We'll write less than or equal to, and then bring down the 3 to the right there. And now, again, we'll get the x by itself. This time we'll divide all 3 sides by 2. -3 over 2 is -1.5. Less than or equal to. 2's cancel out, so we have x left over. Less than or equal to 3 over 2 is 1.5. So now we have x by itself in the middle side. So this is all the numbers between -1.5 inclusive and 1.5 inclusive. So just like before, for the previous inequality, we'll shade this on a number line. All right, pretty much the same kind of idea as before, just different numbers. All right, and just as before, we'll get the solution and interval notation. So this time we have a bracket, -1.5, comma, 1.5, bracket. And that's how to solve an inequality that's an absolute value less than or equal to any positive number.